Mic test, mic test. Testing 1, 2, 3. Alright, good morning everyone. Welcome to Lead. And so let me do a quick check on my mobile, make sure everything is set up correctly. Alright, good morning everyone. Welcome to another session of Data Science Clinic, where we are going to talk about can we do machine learning and AI if we only have small data. So I believe that AI machine learning is one of the hot topics in 2019, 2020, and a lot of people are still wondering like, how can I venture into machine learning and artificial intelligence? And do I need a lot of data? Do I need a lot of computational power? What if I don't have access to those sort of data? Do I really have to gather those data before I can proceed? Okay. First of all, there is a myth that when it comes to machine learning and AI, the first thing that comes to our mind is usually big data, and the notion of big data is used, I think, wildly used, crazily used since about 2012, 2013, and it hits its peak about 2015, and then it starts to die down after a couple of years. So I'm not going into the whole history of big data and then why big data is sort of dying today. The main reason why we hardly talk about big data anymore these days is very simple, because the everyone is used to big data already, right? And second thing is that many companies realize that a lot of time the consultants told them like, oh, you need these big data systems, you need Hadoop, you need Cloudera, you need Teradata, because companies like Google, Facebook, they are using it, right? So they are reliable and they are proven useful. But what many companies then realize is that, hey, I'm not Google, I'm not Facebook, so I probably don't need such a huge computational powers or huge storage just for my company data. So in order to satisfy the criteria to be classified as big data, there are three things that you need to remember. Okay, there are three criteria that need to meet in order to be considered as big data. Now, number one is volume. Okay, volume, as many people know, volume means a lot of data. Yeah, like 20 years ago, 128 megabyte thumb drive or USB flash drive will keep you happy for quite a while. But in today's world, it's actually not the case, right? Whenever you get a mobile phone, for example, the latest iPhone, you're looking at least 128 gigabyte. And the reason behind the needs of such a big storage, or the driver behind the increase of our storage, is mainly because of unstructured data. So we used to store only numbers, and these numbers are basically like spreadsheets or relational databases. So those data numbers are very easy to compress, and they basically occupy a very small space. But today, the types of data that we have is no longer just tables or databases. We have all sort of funny things like photos, your web logs, your audio data, and all these are considered part of the unstructured data. And all this unstructured data mainly comes from social media, right? So you have, if you talk about text documents, you have tweets, you have Facebook statuses, and if we talk about images, you have Instagrams, and you have videos platform as well, like YouTube, and this year, and then in the coming years, like basically when 5G has arrived, or it has been rolled out in some countries, right? When 5G is finally getting more popular, one of the key thing here is all the short videos like TikTok, Douyin, and those are different types of unstructured data. Now, the other characteristic of big data is velocity, means the speed. So we used to process data in a form of batch processing. So if you look at, say, companies' data, right? You process data in a batch. So you don't process data in the stream. You don't process data in the form of, like, let's say, real-time data. So, for example, you have data that's monthly data, you have weekly data, you have daily data, and you look at banks, right? When they do posting, they only do posting for company accounts. They only do posting at a certain period. They don't do real-time posting, meaning that when company A wants to transfer X amount of money to company B, it doesn't happen in real time, right? You have to at least wait for a couple of hours before your receiving party can see the money. So that's batch processing, and then periodic processing is like at the end of the day they process the data. So we have some data that is near real time, like for example Facebook status, Instagram. You upload the pictures, upload a video, you can see it in about 3 to 5 minutes time. Or if you watch a basketball match, that is considered a live broadcast, but it's a bit delayed, and also your stock prices as well. What is real time is things like your Grab. Okay, when you order a car, when you order some food, things need to be happening in real time and give you feedback. Where's the driver now? How far the driver is away from you? How long you need to wait? Okay, so this is just a recap of what is big data. So my next question is, if big data is really that useful and is fundamental requirements when we build machine learning models, or when we build like AI applications, then why not everybody gathers big data before they begins their project? Yeah, this is something that you have to think about. Right? Why not everybody gathers big data before they begin their project? So the main reason behind is, number one, it's expensive to gather data, and gathering data is especially when we gather. Okay, let me give you a few examples. What I mean by it's expensive to gather data. Now, let's look at some industry that we have been talking about. We want to disrupt, like I put it this way. There's some of the industry that at least for myself I have been wanting to disrupt for a couple of years, which is number one, accounts, and number two, legal or laws, right? So accounts, if you want to build an automated AI system for accounting, it shouldn't be that hard, because accounting basically just some transactions, and there aren't too many varieties in terms of the data. There are no pictures or audios or videos for accounts. But if you want to get the data set for accounting, especially audited data before and after the intermediate processes, it's very hard to gather this data, even okay, if you are working in an accounting firm. Unless you do it yourself, you do it manually, and you diligently go and label those data with before, after, and you document all the process. Otherwise, it's very hard to get an audited account with all the annotation that's needed, or the processor. The second thing is legal contracts with keywords or annotated. It's not hard to find contracts. You can always download legal contracts using templates from anywhere on the internet. It's not hard to do so. But if you want to find a legal contract that is manually labeled by the lawyer, saying that, okay, this contract is good for blah particular situations, this contract is good for particular, for example, this contract is for SMP, right? So it's for real estate, and for I don't know, like for example, a particular house with particular criteria, and every single contract looks same but different, right? If you look at the rental contract, some owners will requirements, every owner's requirement is different. Their basic requirements are the same, but individual requirement is different. So how do we allow AI models, AI applications to help us to customize the contract for everyone? It's easy to use AI, or you don't even need AI, like natural language processing, to spot the keywords, but it's not easy to get AIs to analyze your contract and come with something that is useful. Okay, let's talk about something that is in a different industry. Okay, let's talk about manufacturing. So in manufacturing, we always want to say do predictive maintenance, and in order to achieve that, you need logbooks, right? You need to have access to logbooks data with all the subjects, all the description of the problems, all the steps taken to fix the machines, and with the details like when is the machine installed, when was the last maintenance day, the details of the machine, the age of the machine, is it second hand, is it first hand, etc., and which components are new, which spare parts are missing, all sort of things, right? So I spent a good 2 to 3 minutes just to tell you all the processes, and if you think about it, right, you can't just get a normal people just without domain knowledge to go in and fix those data and to collect those data for you. So you need a professional to collect those data, and professionals are not cheap, right? If you think about the man hour cost for a lawyer, for an accountant, for an engineer, yeah, it's very expensive to collect data. Now you might want to ask me, like, Dr. Lau, what about we get those transaction data, for example, web logs, for example, like transaction data from our POS systems, from our point of sale systems, and then we can just analyze those data, right? Yes, you can get those data, and those data usually come in bulk form, right? You can easily get 1 million data points from Tesco, Justco, or Lazada, Shopee. Yes, you can easily get those data, and they have customer data as well. Yes, but remember, those data are unlabeled data. So those data are good for analysis, good for us to do some preliminary understanding. Basically, we look at the content, we look at the patterns, we look at the structures, we look at the trends. Yes, those are good, right? Those data are good for that purpose. But if you want something that's meaningful, if you want something like, for example, I want to build a recommendation engine, I want to build a personalized recommendation system, like to recommend what items my customers need to buy, right? Even if you want to do that, that process itself, yeah, is not simple, it's not easy, because you need someone to look at the data, to look at the groupings, to look at the segmentation, and see which one is meaningful, which one is not meaningful, and you need to undergo a lot of testings as well. Okay, so to gather meaningful data, useful data, the process is expensive, and in technical term, we call it label. Yeah, we call it label data, meaning that data that has been marked by a human, usually manually, to check and make sure that the data is good for building machine learning models. So the second thing is, whenever it comes about you collecting data for machine learning. The thing is that you probably have not exhausted all your possibilities. Usually, it's like, okay, you try to build something, and then you look at your existing models. Let's say you use a classification model and to segmentize your customers, and then after a while, say after 1 or 2 months of working on it, experiments, and then you realize that, hey, the performance is not good. So you went ahead and Google, and then you realize that, oh, a lot of people are suggesting deep learning, and they are saying that, oh, deep learning is very good. It can be used for image recognition. It can be used for security. It can be used for playing chess. Yada. But the thing is, you haven't exhausted all the possibility and all the different types of data, and then you start to think about, oh, that is mainly because my data is too small. And when it comes to data is too small, there are two dimensions, right? It can mean that you have too little rows, meaning that you don't have enough entries, or you have too little columns, meaning that you did not collect enough data of the particular data points. Now, personally, I think both are possible, right? But is when it comes to column data, meaning that you don't collect enough features and some things that you usually miss out, yes, that is possible. That's definitely possible. And sometimes the process is irreversible, meaning that you have done let's say you've conducted a survey, and then you did not ask for a particular data from particular information from the respondents, and you don't have the chance to do it anymore. So that is possible, but it doesn't mean that the more data that you collect, I mean, it's safer to collect more data and to say that your model will become better, lah, yeah. And the second thing is that when you are doing that, right? Uh, the second thing is when you are doing that, you let me think of how do I put it in words. Okay, so when you try to collect more columns, it doesn't mean that you it will guarantee to improve the models itself. You get what I mean? And so if you just blindly jump from that and then go and run another round of data collections, and you might realize that, hey, you're actually doing something wrong. So um, I would like to suggest you to try different things before you decided that you need a bigger data set. Okay, you really need big data. So for example, have you tried data from different data sources? So if you're using customer data from a particular state, let's say you get your customer data from Johor, have you tried your data set from Selangor, from Penang? Some data or some models that doesn't work on particular state. It could be because of your data collection, your data sampling mechanism is wrong. There are many different possibilities that is not so obvious to us. So I would suggest that you at least try data from different data sources. And the second thing is segregate your data into smaller subsets. Sometimes you do have good data, as in you have a reasonable amount of data. Let's say you have 10,000 data points of your customers countrywide, right? But you dump all of them together into a single model, meaning you did not segregate your data. You did not, say for example, you did not separate them even based on their age, based on their gender, or based on their location, based on their occupations, or based on a combination of different subsets. And you did not try to slice and dice your data and before put it into the model. So garbage in, garbage out, right? You put in dirty data and then it comes out, the performance wouldn't be good as well. And the next thing is you probably did not try another set of features. So you have been collecting whatever your seniors, basically what you have been doing in the past and what you are doing right now. So you're basically carrying out the same operations from the previous previous projects, but then sometimes there are other features that you did not think about. For example, in HR analytics, right, we often did not take into consideration of their marital status, but sometimes marital status is one of the key factors that causes people to leave their positions and to leave their jobs, and sometimes because of their place of origin, right? It could be because a lot of people they left their hometown and come and work in KL, and then after 5 to 10 years they need to go back. So there are a lot of reasons that can cause somebody to resign from a company, and the two factors that I mentioned are usually the factors that HR people don't really think that is a factor that cause people to resign. So what I want to share with you is when you have exhausted all the possibilities, remember this, you haven't, right? There are definitely a lot of other things that you can try to improve your current model until you claim that you can really confidently claim that, okay, I've exhausted all the options. In other words, right, getting bigger data sets or gaining big data is not the only way out. All right. So um, so go back to what we want to discuss today. Today, data science clinic is about using AI, ML to build AI. So what to do if you only have a small amount of data? Okay, first thing first, use a simple model. So a lot of time when people look into as was mentioned before, right? You complicate the problem yourself, or you look at the tutorials. You must be thinking like, oh, I need deep learning, right? And not just you as a normal person. Beginner data scientists, they often got influenced, they got excited because of the media, influenced by media and the hype of AI and deep learning. They like to use very advanced models like TensorFlow, Keras, PyTorch. These models are good when you have met the requirements and we have large amount of data. Okay, and but the key consideration here is that the amount of data that you have is so huge that the traditional machine learning models either take too long to compute or the performance is bad. Basically, you hit the bottleneck of the cheap methods already. Then only you look into some expensive methods like this. Okay, when I say cheap method, means that they are, it's not cheapskate. Okay, they are computationally cheap. For example, linear regressions. Have you tried different linear regressions? Have you optimized your linear regression models? Have you ruled out all the possibilities? Or you can use a short version of decision tree. That means decision tree that is not that's not too deep, right? You have a depth of about 4 or 5 levels, and that could be a possibility as well. Try out different models and see and study the difference between different models. And sometimes you can use something more advanced as well, like support vectors machine, right? SVM. And these are common methods, and it has been tested, has been proven useful for many decades, that we have been using it for our machine learning tasks. So it should be able to help you to at least get some meaningful results from the assessing data that you have. Most of the companies that I have worked with, seriously, they don't have that requirements of large amount of data. Yeah? Usually it's because of wrong use of tools. And second thing is, if you have tried all the different models, and you can use an ensemble models as well. An ensemble model means that you don't take the output from a single model, you take the decisions from the combination of multiple models. Meaning you have let's say you have 3 models like I mentioned earlier: linear regression, decision trees, and SVM, right? You can learn the best thing from these 3 models, and you make decisions, combined decisions or ensemble decisions using these 3 models. So the goal of using these methods is that it improves the skills of prediction over any of the contributing models. So each models will contribute their own predictions, let you know where's the error and where's the boundary. And by combining these 3, it can help you to get a much better results usually. Okay. Alright, so to recap, today we discussed about how to perform machine learning and artificial intelligence even if we don't have big data, we don't have large amount of data. And the common cause, because we don't have access to those data and it's expensive to obtain those data. And to be honest, you shouldn't just dive into collecting a large amount of data because it's expensive, right? So you shouldn't just dive in and without understanding the context, the performance, and setting some expected outcomes. And having said that, right, we also need to understand different strategies to roll out machine learning. So number one, I would like to suggest you to start small. So when you think of a machine learning project, a lot of people, they reverse the sequence. They think very big at the very beginning. They think like, oh, these machine learning models, I want it to be used by 1 million users. But before it can be used by 1 million users, you have to make sure that it works for one user. You have to make sure that it works for 10 users, 100 users, 1,000 users. So you start very small so that all the variables, all the impacting factors are within your control. Of course, you might have read some stories about Airbnb, Uber, those sort of things. But remember, by the time you know about this company, they are very big. Okay, when they started small, nobody cares, nobody knows about them. So when they are analyzing their data, they start from very small data as well. Then after you have start small, right, then only you have to think big. Now the think big here, I'm not saying you have to think very big, like, oh, this one has to be used by 1 million, 10 million users. Is that, can you think about the problem that has to be big enough that you can apply it not necessarily to more users from the same vertical. Sometimes you don't go deep, sometimes you go broad, right? So maybe if you are solving a problem that can be used by your finance department, can that be used by HR departments? Can that be used by sales departments as well? Can you, let's say for example, we're building a machine learning models analyzing our customers, right? And your customers pool are not that big. You probably have 5,000, 10,000 customers to begin with. And can what you learn from this model be used by people from marketing department, people from the customer service department, people from the CRM system, for example? So this is what I meant by think big. Okay, don't just restrict to a small problem and keep on focusing on that small problem itself. Of course, you start small, right? And last but not least is you have to think about something that allow you to scale fast. And your model, in order to scale fast, one of the key requirements is that your model shouldn't be too complicated and it shouldn't be too complex. So when other departments, other people take your models, if you want to retrain it, if they want to optimize it, they can easily do that. Yeah. And so before we end, right, what I want to tell you is that don't get me wrong to say that, like, oh, okay, Dr. Lau says that, you know, we just need small amount of data, we can do our job well, yay. And if there are some work that you need to be done with large amount of data, the minimum viable data set, okay, so to speak, right? If you need that sort of data, like for example driverless cars, why Tesla, Google, Apple, they are working so hard to collect data? Because the more data that you collect, technically or supposedly, it will help you to improve your models and make your model better. But in corporate case, normal companies, SMEs, the more data that you collect, your performance is pretty much there, right? Your performance, an 85% accuracy and 87% accuracy and 90% accuracy in your business probably doesn't matter that much. And the difficulty when you hit the marginal effect, right? The difficulty to increase your performance by 1% is a lot harder than before. But for companies, for use cases like driverless car, a 1% increase in accuracy, it could mean that we save millions of lives and millions of minutes on the road. Yeah, reduce a lot of accidents. So you have to think about your use case, and at the end of the day, it's all about the cost, about the cost that you spend. Then say if all you want to build is a simple games using AI like rock paper scissors, right? Few thousand data points or even few hundred data points should be good enough for you to start building some models for generalizations. For example, you want to understand the different contexts between how a kids play rock paper scissors, how an adult plays it, how a man and a woman, the way that they play differently, right? So you can continue to test it under different situations and assumptions, and this will help you a lot in understanding the meaning behind these models itself. Okay, and I'm pretty sure that deep learning models won't be able to help much or help significantly in this case too. All right, so thank you very much for attending today's data science clinic. So I hope you learned a lot from how to use how to build machine learning and AI, even if you have small amount of data. So again, I'm not saying big data is not good. Of course, it'll be good if you can gain access to those data, but you don't have to do it. It's not a requirement at the very beginning. Okay. All right. Is there any questions? Okay, let me know if you have any further questions. I'll be here for another minute. If there's no questions, thank you very much for tuning in, and I'll see you in next data science clinic. Okay, and drop your comment in the drop your question in the comment section, and then I'll answer them even after the live today. All right, thank you very much, and see you next time.